Today we're going to be talking about ions. The subtitle for this is Noble Gas Envy. And if you're not sure, envy means to be jealous. So right now atoms are jealous of the noble gases. The question is, why would these elements be envious or jealous of noble gases? So what we have to remember about noble gases is that they do not react. The reason they don't react is because they have a full valence shell. And remember, in the valence shell are the valence electrons. So they have all the valence electrons possible. Another way of saying this is that noble gases are stable. So the next thing we have to ask ourselves, well, if other elements want to be stable, what would they have to do in order to be stable? What would they have to do to look like a noble gas? Since they do not have full valence shells, other elements would have to either gain electrons remember the E dash stands for electrons, or lose electrons so that they have full shells and they can look like a noble gas and they can be stable. When we're talking about ions, we try to follow what's called the octet rule, where atoms tend to gain or lose valence electrons to attain electron arrangement of noble gases. Essentially all that's saying is so that they look like noble gases. What you have to be aware of is these atoms, these different elements, are not becoming noble gases. They'll just look like noble gases if we look at their electrons. So what we need to remember is the noble gases are this group right here, 8A. And since we're talking about valence electrons, we got to remember, well, how many valence electrons do noble gases? And if you're not sure, remember the group number tells you the number of valence electrons for all the atoms in that group. So for the noble gases, the magic number is 8. 8 valence electrons is our goal. There is a few exceptions, however. Helium is in period 1, which means it only has one shell. And if you remember, that first shell can only hold 2 electrons. So helium is full with 2 electrons in the first shell. Now to do a couple examples just so you understand when atoms will gain or when they will lose electrons. The easiest way to look at this is to start with the Bohr models. So if you remember, the Bohr models, we have our nucleus and then we have the number of shells. The period number, the number on the side here, tells us, well, I just crossed them all out, but tells us how many electron shells an atom has. So if the first example we do is lithium, lithium is right here. So lithium is in period 2, which means it has 2 electron shells, and I have my nucleus already drawn in the center there. So remember, in the nucleus is protons and neutrons, electrons in the electron shells around it. Like we just said, the first shell can only hold 2 electrons. Lithium has only 2 shells, so its second shell is its valence shell. And since lithium is in group 1, that means it has 1 valence electron. If we look at the other information about lithium, lithium has atomic number 3, which means it has 3 protons. Remember, protons are positives. That means right now lithium has 3 positives. Right now lithium also has 3 electrons, and electrons are negative, so it has 3 negatives also. When we get the positive and a negative, they're going to cancel, cancel, cancel. So right now lithium, the atom, is neutral. which means there is no charge on that atom. Right now, lithium is not stable either. It doesn't have full valence shell. So if you look at the valence shell, there's only one electron there. Well, noble gases have 8. That means in order to become stable, lithium would need to gain 7 electrons in order to have the octet, to have 8, to be full. But if you remember, the first shell is full with 2 electrons. So the other option lithium has is just to lose this one valence electron that it has. To move this one electron. So its other option is to lose its one valence electron. So now we have to remember, atoms are very, very lazy. They don't like to do more work than they have to. So what you have to ask yourself, do you think it's going to be easier to gain 7 electrons or to lose 1? Hopefully you recognize that it's way easier for lithium to lose this 1 electron. And the way we demonstrate that, the way we show that it's losing that 1 electron, is we put a circle around it, like a dotted circle, and then we put an arrow going away, showing that it's leaving. We're losing that 1 electron. When lithium loses that 1 electron, it still has 3 protons because we haven't touched the nucleus. So we still have 3 positives. Now, however, we only have 2 electrons, negative, negative. Now, positive and negative cancel out, positive and negative cancel out. What we're left with is 1 positive. There's more protons now. Now lithium has a charge, and the way we show that is we have this symbol lithium, Li, and we show that it's positive with a plus sign. And it's only 1 more proton, so it's just 1 plus. Now if we look at our next example, fluorine. Fluorine is right here on the periodic table. Right there on the periodic table. So it's also in period 2. So I'm going to draw my nucleus. 2 shells. This time, however, fluorine is in group 7, which means it has 7 valence electrons. So I'll have 1. See how the pink shows up? 2, 3, 4, 5, 6, 7. And of course 2 electrons on the first shell. So since fluorine has 7 valence electrons, remember it needs to get to 8 to be stable. So all that would need to happen was fluorine would need to gain 1 electron. Because it has 7, it needs to get to 8. It only needs 1 more. The other option, since that first shell is full with 2 electrons, we could lose all 7 of the electrons. And then we would also have a full shell. So again, what you got to figure out is what's going to be easier. Gain 1 or lose 7. Gaining 1 would be way easier. So the way we show that, instead of having an arrow going out, that was supposed to be a dotted line, we have an electron coming in. Okay? So now fluorine, atomic number 9, means it has 9 protons. So that means it has 9 positives. I'm not going to draw out all the plus signs, but you can if you need to. When fluorine gains this 1 electron, it now has 8 in the valence shell and 2 on the first shell for a total of 10 electrons. And remember, electrons are negatives. So we have 9 positives and 10 negatives. Overall, this is equal to 1 negative. So now fluorine will have a negative charge, and we show that with an F negative. This will be the last example for today. It's going to be beryllium. So beryllium is also in period 2, right next to lithium in fact. So I have my nucleus, 2 shells. First shell is going to be full. Oops. And since it's in group 2, it's going to have 2 valence electrons. So again, to be stable, we need to get to 8 valence electrons for a full shell. So we have 2 already. That would mean we would need to gain 6 electrons. The other option, since the first shell is already full, is we could lose 2 electrons. If we lose those 2 valence electrons, that first shell is already full. So the easiest bet would be just to lose those 2 electrons. And again, we put a dotted line around the electrons we're losing. Put an arrow away. This time we're losing 2, so I need to do it with both the electrons. Beryllium, as atomic number 4, has 4 protons. So 4 positives. When it loses those 2 electrons, now it only has 2 electrons left. 2 negatives. 4 positives and 2 negatives means we have 2 positives left over. So that means beryllium will now have a charge of positive 2. If it's not 1, you have to show the number with it. That way we know beryllium lost 2 electrons. Now an ion is a charged atom. So an atom becomes charged when the protons and the electrons are no longer equal, like I just showed you in those 3 examples. There are 2 types of ions. One of them is called a cation, and the other one is an anion. A cation is when it has a positive charge, and one way to remember that is the T in cation looks like a plus sign. So cations are positively charged, and atoms become positively charged when they lose electrons. Anions are negatively charged atoms. And if you look at the A, the inner part there could look like a minus sign. So if cations become positive by losing electrons, anions become negative by gaining electrons.